Imagine this, a multi-billion-dollar financial trade. It just hangs, stuck for a few critical seconds. Or think about a hospital's life-saving diagnostic machine suddenly going blank right in the middle of an emergency. What's the invisible physical force that underpins these huge systems, letting them actually function? And what happens when just one tiny part falters? Well, the answers lie deep inside, in the very nuts and bolts of our digital world.
Get ready to level up. This deep dive, it's really your essential guide to understanding the tech that's reshaping basically every industry out there. Today, we're taking a really close look, a deep dive into the foundational components that make all business technology possible. Computer hardware. We're kind of cutting through the jargon here, pulling out the most important nuggets of knowledge from Chapter 3 of Technology for Success. Computer concepts. Think of it as a shortcut to being well-informed.
Right. And our goal today, our mission, is to arm you with that fundamental understanding of hardware, so you can confidently choose, use, and even support the technology you'll encounter in, well, any business field. We're talking everything from word processing, spreadsheets, all the way to complex data analytics. You'll really get the core concepts of hardware and software and see how they power those essential business productivity tools. Okay, before we really plunge into the core of the machine, though, make sure you hit that like button, subscribe, share this deep dive. You don't want to miss these insider tips that could really position you for a bright future in whatever career you choose. And remember, you'll find extra resources plus a link to the chapter we're diving into right down there in the description below. Okay, so let's pick things off right at the beginning. When we talk about computer hardware, what exactly are we talking about? It sounds kind of broad, but I know it's actually very specific stuff.
Yeah, it sounds technical, but it's simpler than you might think. Computer hardware is basically all the tangible physical parts of a computer system. You know, think of anything you can actually reach out and touch or see, from the really tiny chips and intricate wires hidden deep inside the machine, all the way out to the keyboards and printers you use every single day.
Okay, so it's not just the obvious stuff like the screen and the keyboard. It's literally everything physical, even the components tucked away inside the case that we don't normally see. It's like the bones and muscles of our digital tools, right? And fundamentally, every computer system, no matter how big or small, runs on this basic cycle: input, processing, output, and finally, storage. That's the core loop for everything.
Exactly. Input, processing, output, storage. That cycle underpins everything. And for you, especially as a Dr. Sam Pack College of Business student, this isn't just, abstract theory. In today's world, 2025 and beyond, computers aren't just helpful. They are absolutely essential business tools. They're woven into pretty much every single aspect of a company's operations. Think marketing, accounting, day-to-day admin tasks. Businesses rely completely on computing power for product design, data analysis, critical communications, you name it.
That's a really crucial point, because understanding the hardware means you know what makes the technology actually work. It empowers you. It means you can confidently choose the right tools, use them effectively, and even support the computers you'll need in whatever field of business or entrepreneurship you go into. You're making informed choices, not just guessing. That's a huge advantage.
Yeah.
All right, so if we were to metaphorically open up this machine, what are the absolute core components, the fundamental building blocks we really need to wrap our heads around first?
Yeah, we can definitely simplify it. It really boils down to the big three. First, the central processing unit, the CPU. Second, memory, and that includes both RAM and ROM. And third, storage, which is where all your files live long term. These three work together constantly, making everything else happen. Okay, let's start with the CPU. It's often called the brain of the computer, and for good reason. Its main job is executing instructions. Every single thing you ask your computer to do, like opening a file, sorting data in a spreadsheet, rendering a graphic, it all gets broken down into these tiny machine-level instructions that the CPU has to process.
It's kind of mind-boggling when you think about the scale, isn't it? Modern CPUs are built on a single tiny chip, a microprocessor that rolled billions, literally billions of microscopic transistors. That density, driven by Moore's law for so long, is incredible. And as we hit physical limits, the focus has shifted, right, towards multi-core designs, getting more processing power through parallelism.
Exactly, and that directly leads into how we measure CPU performance. Key things to look at are clock speed measured in gigahertz or gigahertz. That tells you how many instruction cycles it can run per second. Consumer chips are typically, somewhere between 1 gigahertz and 5 gigahertz these days. But it's not just raw speed. There's also the bus width. Think of it like lanes on a highway for data. A wider bus, maybe 64-bit, means more data moves at once. And yeah, the big trend is multi-core designs. Having multiple processing brains or cores on one chip allows for much better parallel processing and makes multitasking way smoother.
That speed is just phenomenal. But beyond the numbers, where does this really matter in the business world? What are some critical situations where a fast CPU isn't just nice to have, it absolutely essential?
That's a great question because the business impact is significant. It's not just about the gigahertz number anymore, especially looking ahead. The real advantage now is often parallel processing power from those multi-core CPUs. Think of it like this. Your multi-core CPU lets you run a huge financial model simulation, jump on a critical video conference call, and maybe render a high-res marketing graphic all at the same time without the whole system bogging down. For accounting and finance specifically, a fast CPU is vital. Processing large financial models, running complex audit software, analyzing investment data, it all needs horsepower. A slow processor makes database queries incredibly painful.
Oh, I can imagine waiting ages for a report to generate.
Exactly. Lost time, missed opportunities. And in marketing or creative roles, powerful CPUs are crucial for graphic design, quickly rendering video ads, creating brand content efficiently. Overall, a faster, more capable CPU just lets you run all your essential business apps, spreadsheets, databases, simulations much more efficiently. Less waiting, more doing.
Okay, so if the CPU is the brain doing the thinking, how does it actually keep track of everything it's working on right now? What's that immediate fast access workspace it uses?
That immediate workspace is random access memory, or RAM. It's super fast, but it's temporary. We call it volatile memory. It holds the data and programs that are actively running. The random access part just means it can read or write data anywhere in the memory really quickly, in any order. But here's the key thing. When the power goes off, poof, everything in RAM disappears. A good analogy is like your desk while you're working. It holds the files, the notes, the tools you need right now for your current tasks. But once you pack up, turn off the lights, leave for the day, that desk gets cleared off, right? RAM is like that desk space. Now, there's also even faster memory called cache, often right on the CPU chip itself. Think of that like the little pile of papers right at your fingertips on the desk of stuff you need constantly. Both RAM and cache are crucial, but RAM is the main temporary workspace.
Ah, okay. That makes sense. That's why my laptop might start to chug and struggle when I have like a massive Excel spreadsheet open, a video call running, and I'm trying to research something online. It's running out of that immediate desk space, that RAM.
Yeah.
So for business students, this is key, right? Having enough RAM is absolutely critical for running multiple applications smoothly, doing complex calculations, or working with graphics without those frustrating slowdowns. Not enough RAM is often the bottleneck.
Precisely. And besides RAM, there's also read-only memory, or ROM. Now, this is non-volatile, meaning its contents stick around even when the power is off. ROM holds essential firmware, like the BIOS, the basic input-output system, or its more modern replacement, UEFI. These are the first instructions the computer runs when you turn it on. They initialize all the hardware, check that everything's working until the computer had to find and load the operating system. And tucked away with the BIOS UEFI, there's usually a little bit of CMOS memory, powered by a tiny battery, like a watch battery. That's what keeps track of the system, date and time, even when the computer is totally unplugged.
All right, so RAM is the busy temporary workspace. But we definitely need a way to keep our files, our documents, our photos, everything for the long haul. That's where storage comes in, yeah. What are the main options there for keeping our digital stuff safe permanently?
Exactly. We need that long-term archive. Storage devices are designed specifically to keep data persistently, even when the power is switched off. Historically, the main internal storage was the hard disk drive, the HDD. These are the traditional mechanical drives. You can almost picture like a tiny record player inside. Data gets stored magnetically on these spinning platters read by little heads that move back and forth. They store binary data by magnetizing tiny spots. Think magnetized as a 1, not magnetized as a 0. They can hold a lot of data relatively cheaply, but because they have moving parts, they're slower and more fragile than the newer options.
And those newer options have really taken over, haven't they? We still see HDDs, especially for bulk storage, but solid-state drives, SSDs, they seem to be the standard now in most laptops and desktops. They're way faster, more durable, use less power because there are no moving parts, right? It's all flash memory chips. And then for external storage, we've got the ubiquitous USB flash drives. And optical discs, CDs, DVDs, Blu-ray, they feel pretty much obsolete now, though they were huge for a while.
Yeah, SSDs have been a game changer for performance, but what's really transformed storage, especially for business, is cloud storage. This is basically a different model. Your digital data isn't just living on your local device, it's stored on powerful servers in huge secure data centers somewhere else. Think Google Drive, Dropbox, Microsoft OneDrive. Your files are accessible from practically anywhere on any device as long as you have an internet connection. It's massive for collaboration and data safety.
Absolutely. And the business uses for all these types are huge. In accounting and finance, think daily backups of critical financial records to the cloud or an external drive. That's non-negotiable for guarding against data loss, ensuring compliance, business continuity. For marketing or entrepreneurs, you're storing large assets, high-res images, videos, detailed business plans that can eat up storage space quickly. And cloud storage, like you said, is indispensable for teamwork. Teams can collaborate on documents in real time, access project files from anywhere. It keeps data safe and makes group projects so much easier. So, a practical takeaway for students. Understanding these options prevents that panic when you run out of disk space right before a deadline, or helps you know why regular backups to an external drive or the cloud are so important. This ties right into demonstrating proper file management techniques, which is a key learning outcome. Okay, so we've talked components, but the computers themselves come in all shapes and sizes, right? Each designed for different tasks. What are the main types we should be aware of as future business pros? How does the form factor impact what they're good for?
Yeah, the range is huge. You've got the personal computers we use every day, all the way up to massive systems running global operations. Within personal computers, you have desktops, usually separate pieces. A tower with the main components, a monitor, keyboard, mouse. They often offer the most bang for your buck in terms of power and are easier to upgrade. Then you have all-in-one PCs. These integrate the tower components right into the back of the monitor. Save space, look sleek, but usually a bit less powerful for the price and harder to upgrade. Then for mobility, obviously, laptops and tablets. Laptops are the classic portable powerhouse, compact, battery-powered, great for working on the go, though upgrades are typically limited to maybe RAM or storage. Tablets take portability even further, mainly using touchscreens for input. And then you have those two-in-one hybrids that try to bridge the gap, often with detachable keyboards, giving you tablet flexibility and near laptop productivity. And we can't forget mobile phones. They're basically powerful mini computers now, designed for long battery life and being lightweight. But they pack in so much hardware, amazing cameras, GPS, sophisticated sensors, making them vital business tools too.
Right. And then we scale up considerably. You mentioned mainframes. Those sound serious.
Oh yeah. Mainframes are enormous, very expensive computers used by governments, large banks, airlines organizations that need to handle just massive volumes of transactions or calculations simultaneously. Think airline reservations, global financial trading, census data processing. Then you have mini computers smaller than mainframes but still powerful, often dedicated to specific tasks like controlling industrial processes, running scientific labs, or managing specialized databases. At the absolute peak performance-wise, you find supercomputers. These cost hundreds of millions. They're built to tackle incredibly complex calculations for things like weather forecasting, drug discovery, nuclear simulations problems that might take weeks on other systems. And a newer category is warehouse-scale computers. These are huge clusters, often thousands of computers working together, powering cloud services, software as a service, or SaaSes. Here, the focus is often on cost per operation and energy efficiency rather than raw single machine speed. The software is often designed to handle individual computer failures within the cluster. And finally, embedded systems. These are everywhere, often invisible. Tiny processors in your smart thermostat, your car's engine control unit, medical devices. They range from simple, cheap 8-bit processors to complex systems, often with cost and reliability being the absolute top priorities.
Wow, okay. That range is incredible, and it connects directly back to business and student life, doesn't it? Managers might need that balance of power and portability from a laptop or tablet for presentations or reports. Entrepreneurs starting out need to pick affordable but capable hardware, so understanding specs is key. And as a student, you might choose a powerful desktop if you're doing graphic design or heavy data analysis versus a lightweight tablet or laptop for taking notes and lectures. And we see these different scales everywhere in industry. Banks need those data centers. Retail stores rely on central servers for inventory. Manufacturing uses embedded controllers and robots. Hospitals depend on specialized hardware and diagnostic machines. Understanding this helps you see how business software applications integrate across all these different platforms.
Okay, let's boil down this first lesson. Key takeaways for you as a Dr. Ciampa College of Business student. First, those core concepts. CPU, memory, storage. They're fundamental. Understanding them helps you judge a device's speed and capacity. Can it handle the business software you need efficiently? Can it run those complex spreadsheet models or database queries without slowing you down? That's critical.
Right. And second, knowing the different hardware types, desktop, laptop, all-in-one tablet, helps you pick the right tool for the job, whether it's for your coursework now or your future career. Maybe you need that upgradable power of a desktop for heavy lifting at home, or the grab-and-go convenience of a laptop for meetings and classes. Knowing the trade-offs is key.
Third, storage and the cloud. Especially cloud storage like Google Drive or OneDrive, it's really essential now for group projects, ensuring everyone has access, and for keeping your important data safe. Understanding different storage types like SSDs versus HDDs and knowing about backups helps you avoid data loss disasters and manage your files effectively. This directly hits that learning outcome about demonstrating proper file management.
Fourth, connecting theory to practice. These hardware choices directly impact what you can do in business roles. Fast processing for finance, ample storage for marketing assets, reliable systems for entrepreneurship. It's about making smart investments in the tools that drive your productivity.
And finally, number 5, empowerment. This knowledge lets you troubleshoot basic issues yourself, make smarter decisions when buying or upgrading, like adding more RAM for better multitasking, and even confidently recommend technology solutions in a business context. This directly helps you achieve that learning outcome of describing the fundamentals of IT concepts. Hardware, software, security, and privacy. It's foundational knowledge. All right, moving on. Input and output devices, or I/O devices. These are basically the essential gateways, the bridges through which we communicate with our computers. We use them to send information in that's input and to get the processed results back out, that's output. They translate between our world and the digital realm.
Yet, this is where it gets really hands-on, isn't it?
Yeah.
How we actually talk to the machines and how they talk back to us. It's this constant two-way street, and the sheer variety of devices is huge. Understanding these is absolutely key for things like creating business documents, building presentations, managing data effectively in databases, all core skills.
Okay, so input devices. Their job is to send data or instructions into the computer. They let you capture information, text, clicks, sounds, images for the computer to work with. The most common ones you use constantly are your keyboard, probably the most frequent input device for typing text, numbers, commands, using all those different keys. Typing keys, numeric keypad, control keys like Alt and Control, special keys like Enter, Shift, function keys F1 to F12, all vital for creating business documents.
And the mouse, of course. That ubiquitous pointing device for moving the cursor, clicking, selecting, dragging things around on the screen. Essential for navigating spreadsheets, designing presentations, interacting with software. Touchscreens are fascinating too because they double as output devices, showing you information. But their primary input function is allowing that direct, intuitive touch interaction. Then you've got scanners for digitizing paper documents, like reading a report and sending it to your PC. Microphones capture audio for maybe recording narration for a presentation. And cameras or webcams capture images and video, crucial for marketing content or video conferencing.
And beyond those everyday examples, there are lots of specialized input devices for specific fields. Joysticks, for example, you see them in CAD, computer-aided design systems, and obviously video games. Trackballs offer an alternative to mice, sometimes built into laptops or used for ergonomic reasons. Light pens let users draw or select directly on older monitor screens, good for precision work. Educational settings might use optical mark readers, OMRs, for grading multiple choice tests quickly by recognizing pencil marks.
And in business, you see things like optical character readers, OCR technology, which scans printed text and turns it into editable digital text, super useful for data entry from invoices or documents. Banks heavily rely on magnetic ink card readers, MICRs, to rapidly process checks by reading that special magnetic ink. And barcode readers are absolutely everywhere in retail and logistics, scanning those black and white lines to identify products instantly for inventory tracking and point-of-sale systems. All these devices are about getting data into the system efficiently, which is fundamental for managing data with database software later on.
Okay, now let's flip the coin and look at output devices. These convey information from the computer back to you or out into the world. The most obvious one is your monitor, technically called a visual display unit, or VDU. It's the primary way computers show us visual information, text, images, videos, charts. It works by lighting up thousands or millions of tiny dots called pixels. The more pixels, generally the sharper the image. We've mostly moved away from the old bulky CRT monitors to thinner, lighter, more energy-efficient, flat panel displays, LCDs, LEDs, OLEDs that you see on desktops, laptops, tablets, even calculators.
Right, and printers, of course, take that digital information and put it onto physical paper. You mentioned two main types,
Yeah, broadly speaking, impact printers physically strike an ink ribbon against the paper to form characters. Think of old dot matrix printers or maybe daisy wheel printers. They can be noisy but are sometimes still used for multi-part forms because of the physical impact. Then you have non-impact printers, which are much more common now. Laser printers and inkjet printers fall into this category. They form images without striking the paper using toner and heat or spraying tiny ink droplets. They're faster, quieter, offer excellent quality, and handle graphics in different fonts really well.
Okay, and beyond monitors and printers.
Well, you've got speakers and headphones for audio output. Projectors are essential for displaying visuals on a large screen for presentations in classrooms or boardrooms. For specialized design work, like architectural blueprints or engineering diagrams, you might use a plotter, which draws precise lines using pen-like devices. These often need a good graphics card to drive them. There are also output devices for accessibility, like Braille readers that translate on-screen text into tactile Braille characters for visually impaired users. And inside the computer, the video card, or graphics card, is crucial. It's fitted onto the motherboard, and its job is to process image data and send it to your monitor or projector. A powerful video card is essential for gaming, video editing, CAD work, and even driving multiple displays simultaneously, which is super useful for analysts watching lots of data feeds. And let's not forget GPS, the Global Positioning System. While it receives satellite signals input, its primary function for the user is outputting your location and navigation information, often integrated right into smartphones and vehicles now.
It's really cool how some devices actually do both, isn't it? They let us send data in and get results back all in one package. How do these hybrid devices kind of change the game for how we interact with tech?
They're incredibly versatile, these hybrid I/O devices. Because they handle both input and output, they often streamline how we work and make interactions much more intuitive. The absolute prime example is the touchscreen. It acts as your monitor, displaying output, but you also interact with it directly using touch for input tapping, swiping, pinching. Think smartphones, tablets, ATMs, information kiosks in malls or airports. They make complex interactions possible without needing a separate keyboard or mouse.
Yeah, totally. And what about storage devices? Do they count? Like an external hard drive?
That's a great point. Yes, external storage devices are definitely hybrid. An external hard drive stores your files that's outputting data to the drive for storage. But then you access, read, and modify those files that's inputting data from the drive back into the computer. They're portable, great for backups, transferring huge files, or just adding more storage capacity to your main computer, essential for managing data across different machines or securing important work.
And the little USB flash drive too, right? Same principle.
Exactly the same principle, just smaller and usually faster access than external HDDs, though often less capacity. You copy files onto it, output, then plug it into another computer, and that computer reads the data from it, input. Super convenient for quick file transfers, maybe carrying a presentation, creating a bootable rescue disk, or having an emergency backup of a critical document. Now, connecting all these devices, thankfully, many of them are what we call plug and play. You just plug them into the correct port. USB is the most common, but also HDMI for video, audio jacks, and the computer usually recognizes it automatically and installs basic drivers to make it work.
That plug and play feature is such a lifesaver, seriously.
Yeah.
But it doesn't always work perfectly. Or for more specialized hardware, right? Sometimes you need specific software.
Correct. For some devices, especially more complex ones like high-end printers, scanners, or specialized scientific equipment, you often need to install a specific piece of software called a device driver. Think of a driver as a translator. It's software that allows your computer's operating system to communicate properly, to understand and control that specific piece of hardware. Without the right driver, your fancy new printer might just sit there or only offer very basic functions. Okay, let's wrap up Lesson 2 with the key takeaways for business students. First off, just practical skills. Being able to recognize common input and output devices helps you set things up quickly or troubleshoot simple problems. Knowing a keyboard as input and a monitor as output seems basic, but it helps you figure out where a problem might lie. Saves time, builds confidence.
Yeah, definitely. And second, understanding the business use cases. Every single department uses I/O devices constantly. Marketing needs cameras and microphones. Accounting needs fast keyboards or numeric keypads. Operations relies on barcode scanners. Knowing which device fits which task helps you work smarter and more efficiently. This directly feeds into your ability to create those business documents, presentations, and manage data effectively.
Third, think collaboration and presentations. Devices like projectors, interactive whiteboards, even just good webcams and microphones for remote meetings. They're crucial for sharing ideas and working together. Knowing how to connect your laptop to a projector quickly before a big group presentation makes you look prepared and professional. It helps you create those impactful business multimedia presentations.
Fourth, considering the tech economy and entrepreneurship. If you're starting a business, you need to choose the right hardware. What kind of point-of-sale system, what scanners for inventory, what printers for shipping labels. This knowledge informs smart purchasing decisions. It also ties into using web-based tech for ethical research. You need the right input-output tools to access and present that information.
And finally, just general efficiency. Being familiar with peripherals like printers, scanners, external drives lets you make the most of resources, whether it's on campus or in your first job. Printing handouts, scanning receipts, backing up files, knowing how these tools work makes everyday tasks smoother. All of this supports those core learning outcomes, creating documents, presentations, managing databases, because you need I/O devices to interact with the software and get your work done.
Okay, so we know what hardware is, we know the main components, we know how to interact with it using I/O devices. But the next really critical piece is keeping it all running smoothly, right? What makes a computer perform well and last longer? And, maybe more importantly, what do we do when things inevitably start to go wrong? Because, let's face it, tech doesn't always behave.
That's exactly right. Keeping hardware in good working order is crucial, especially in a business context. Downtime is expensive. Even just a few seconds of computer lag can mean missed opportunities in finance or frustrated customers in retail. Proactive maintenance is key. First, let's touch on performance factors again briefly. We mentioned CPU clock speed, gigahertz, and bus width earlier. These directly impact how fast the computer executes tasks. When comparing systems, people often look at benchmark scores, which are standardized tests designed to measure and compare performance across different machines or components.
Gotcha. So how do we keep things running well? What's involved in regular maintenance?
A lot of it is actually pretty simple. Basic care. Cleaning is important. Use a soft, lint-free cloth for screens. Compressed air, the kind specifically for electronics, is great for blowing dust out of keyboards, vents, and fans. Keeping those air vents clear is critical for preventing overheating.
Yeah, the overheating issue. My old laptop used to sound like it was preparing for takeoff because the fan vents were clogged with dust. Learned that lesson the hard way.
It's a common one. And this brings up a good point. How often do you, the listener, actually back up your critical files or clean out your devices? You see discussions online, maybe on Reddit, where some people do it weekly, others, well, almost never. But consistent care really does make a difference. For internal cleaning, if you're comfortable opening the case, using 99% isopropyl alcohol on a lint-free cloth or swab can clean contacts. Just make sure it's fully dry before powering back on. But definitely avoid regular vacuum cleaners, static risk, and shop air compressors due to moisture. Power protection is another big one. Always use a surge protector at minimum. Even better is an uninterruptible power supply, a UPS. This guards against power spikes and gives you battery backup for a short time if the power cuts out suddenly. In retail, that could be the difference between losing a sale during a brownout and being able to complete the transaction or shut down gracefully. And data backup. I know we mentioned it with storage, but I really can't stress it enough. Always back up your important data. Use cloud services, use an external drive, use both. If your main drive fails, and they do fail, having a backup means your work, your photos, your business records are safe. This is fundamental to proper file management.
Absolutely critical. What else?
Keep your software updated. This includes device drivers and firmware. Your operating system usually has tools to help manage these updates. Updated drivers ensure your hardware communicates properly with your software and can often fix bugs or improve performance. And finally, physical protection. Use protective cases for laptops and mobile devices. Try to control the environment where your computer lives. Avoid extreme temperatures or high humidity. Simple stuff, but it adds up to longer lifespan. Hashtag 3.1.3. Troubleshooting Common Hardware Problems 2025 Deep Dive.
Okay, so maintenance is key. But what happens when things do go wrong? What are the common warning signs, the red flags that tell us something's up with the hardware? And how do we start figuring out what the problem actually is, especially if we're not, super technical?
That's the million-dollar question, isn't it? It really starts with recognizing the symptoms. Is the computer not turning on at all, or maybe restarting randomly? That often points to power supply issues, or maybe a critical component failure. Is it overheating? You might notice the fans running constantly loud, the case feeling hot to the touch, or performance suddenly dropping. That's called throttling. Are you seeing frequent crashes, maybe the infamous blue screen of death, BSOD, in Windows? That could be RAM problems, driver conflicts, or even a failing hard drive.
What about weird noises, like clicking or grinding?
Yes. Clicking, grinding, whirring noises from the case often indicate a mechanical hard drive, HDD, is failing. That's a serious warning sign. Back up immediately if you hear that. Other signs could be graphical glitches or artifacts on the screen, graphics card issue, USB devices not being recognized, port or device issue, or just general sluggishness that wasn't there before. Maybe your internet connection keeps dropping, network card or router issue. Recognizing these tells is the first step. When you encounter a problem, the first steps are usually pretty straightforward. Check all your cables, power cords, monitor cables, network cables. Make sure they're plugged in securely at both ends. Sometimes a loose cable is all it is. Try restarting the computer. Seriously, the classic turn it off and on again fixes a surprising number of temporary glitches. Make sure your operating system and drivers are up to date. Run a virus or malware scan just in case. Check if your storage drive is almost full. That can cause slowdowns.
Okay, basic checks first. What if those don't help?
If the simple stuff doesn't work, you might need to dig a bit deeper, but carefully. If you suspect overheating, make sure the vents are clear. Listen for any unusual beep codes when the computer starts up. Different patterns can indicate specific hardware failures, like RAM or video card. If a specific peripheral isn't working, try plugging it into a different port, or try it on a different computer if possible, to isolate whether the problem is the device or the computer. But always, always prioritize your data. If you suspect a major hardware failure like a dying hard drive, back up everything you can immediately before doing anything else.
Right. Back up first, troubleshoot second.
Exactly. And if you're not comfortable opening the case or dealing with internal components, or if the problem persists, that's when it's time to call an IT support or a qualified technician. Knowing your limits is important too.
So if a component does fail, or seems to be failing, is it always game over for that part? Or are there ways to kind of restore things sometimes?
It depends on the failure, but no, it's not always a total loss. Sometimes simple restoration steps work. We mentioned checking and reseating cables. Sometimes a component just isn't making good contact. If a monitor isn't working, testing it on another computer helps determine if the monitor itself is bad or if the issue is with the first computer's graphics output. If your operating system gets corrupted, maybe due to a failed update or malware, reinstalling it from your backup media or using the system's built-in recovery options can bring the computer back to life, assuming the underlying hardware is okay. Many devices also have a factory reset option. This wipes the device and returns it to its original software state, which can fix persistent software glitches that might look like hardware problems. But the absolute golden rule, again, is backups. If you have good recent backups of your data, even if the physical hardware is completely toast, you can usually restore your important files onto a new or repaired machine. Data is often more valuable than the hardware itself.
Okay, this is really practical. Beyond just knowing what might be wrong, sometimes you actually need the right tools to perform basic maintenance like cleaning, or maybe even a simple upgrade like adding RAM. What should a business student, or really anyone who wants to be a bit more tech savvy, have in their basic computer toolkit?
That's a great point. Having a basic toolkit can save you time and money on simple tasks. You don't need a professional setup, but a few essentials are really useful. For hardware tasks, definitely a set of screwdrivers. You'll need Phillips head, the cross shape, in a couple of sizes, probably a flathead too. Sometimes you encounter Torx screws, star-shaped, so a multi-bit driver is handy. Ideally, get ones with non-conductive handles, and magnetic tips are a lifesaver for handling tiny screws inside a case. Needle nose pliers can be helpful for gripping small things or bending pins carefully, maybe tweezers too. If you ever plan to work with cables, basic wire cutter strippers with insulated handles are good to have. And critically, an anti-static wrist strap. Static electricity from your body can fry sensitive components like RAM or motherboards without you even feeling a shock. You clip one end to a metal part of the computer case, grounding it, and wear the strap snugly on your wrist. Super important if you open the case.
Okay, screwdrivers, pliers, anti-static strap. What about for the cleaning and diagnostic side?
For maintenance, a flashlight is surprisingly useful for seeing into dark corners of a case. Cans of compressed air specifically for electronics, or even better, a reusable electric air duster blower. Great for clearing dust from fans, heat sinks, keyboards, and vents.
Not the garage air compressor, right?
Definitely not. Too much pressure and potential for moisture condensation, which is bad for electronics. And avoid standard vacuum cleaners, too, that can actually generate static electricity. Lint-free cloths are essential for wiping screens and surfaces. Maybe some 99% isopropyl alcohol for cleaning contacts or thermal paste residue, but use it sparingly and let it dry fully. A small organizer for screws and parts is incredibly helpful so you don't lose them. Cable ties or Velcro straps for managing cables neatly. And always good to have a reliable USB flash drive handy. You can load diagnostic software onto it or use it to install an operating system if needed. And using these tools safely is key. Always use the right size screwdriver head to avoid stripping screws. Wear that anti-static strap whenever you're touching internal components. When using compressed air on fans, gently hold the fan blades so they don't spin too fast and damage the bearings. Common mistakes include buying cheap, low-quality tools that break or damage components, ignoring safety like the anti-static strap, or using the wrong cleaning methods. Just take your time, be methodical. All right, let's wrap up Lesson 3 on maintenance and troubleshooting. Key takeaways for you as business students. First, reliability. Regular maintenance, cleaning, updates, backups prevents those frustrating tech failures, especially during critical times like finals week or when a big project is due. This also directly links to using web-based tech for ethical research. You need a reliable machine to do that work effectively and securely.
Second, efficiency. A well-maintained computer just runs faster. That means less time waiting for programs to load or calculations to finish. Whether you're running financial simulations, designing marketing materials, or just multitasking between different apps, good maintenance boosts your productivity. This helps you effectively use tools for goal-seeking and what-if analysis.
Third, problem-solving skills. Learning basic troubleshooting isn't just about fixing computers. It builds critical thinking and logical deduction skills that are valuable in any career. Being able to diagnose and maybe even fix a simple issue yourself saves time, reduces stress, and builds confidence.
Fourth, cost savings. This is a big one, both for businesses and for you personally. Regular maintenance extends the lifespan of your hardware. Delaying expensive replacements or repairs saves money. Looking after your laptop means it lasts longer through your studies.
And finally, number 5, professional preparedness. In today's world, having some basic IT literacy is often expected, even in non-technical roles. Being able to handle simple issues, understand maintenance needs, or communicate effectively with IT support shows initiative and competence. This all ties back to those core learning outcomes describing IT fundamentals, hardware, software security, demonstrating proper file management through backups, and ensuring your systems are stable enough for ethical research and complex analysis. ###44. Overall course description and learning outcomes recap. So if we take a step back and connect all this hardware talk to the bigger picture, think about the entire BCIS 3205 course. Its focus is on those essential business productivity software tools, word processing, spreadsheets, databases, presentation graphics, data analytics, using the internet effectively for business. All of that software fundamentally relies on the hardware foundation we've been discussing. Understanding the hardware isn't just some technical side note, it's actually a strategic asset because it enables everything else you do with technology in business.
Right. So drilling down, what does this hardware deep dive really mean for you, the listener, and your future career? How specifically does understanding this stuff help you nail the learning outcomes for BCIS 1305?
Well, it prepares you directly in several ways. First, by understanding the physical components, CPU, RAM, storage, I/O, and how they interact, you're much better equipped to describe the fundamentals of information technology concepts, hardware, software, security, and privacy. That's a core outcome. Second, your knowledge of storage options, cloud services, and the critical importance of backups directly empowers you to demonstrate proper file management techniques. You know why and how to keep your digital files organized and safe.
Okay, that makes sense.
Third, having reliable hardware that you understand and maintain ensures you can effectively create business documents with word processing software, create business multimedia presentations, and create databases and manage data with database software. The software needs stable hardware to run on. Fourth, a solid hardware base is essential for being able to seamlessly integrate business software applications. Trying to get different programs to work together on a slow or unstable machine is a nightmare.
Yeah, definitely been there.
Fifth, functional network hardware. Your network card, your router connection is obviously a prerequisite for being able to use web-based technologies to conduct ethical business research. And finally, having robust, well-maintained systems, which comes from understanding the maintenance and troubleshooting we discussed, is absolutely crucial for effectively using tools like goal-seeking and what-if analysis in spreadsheets or other analytical software. Those tasks can be demanding on hardware resources, so you need a system that can handle them reliably to solve problems and make recommendations in a business context. #outro.
So there you have it. Today, we've journeyed through the pretty intricate world of computer hardware. We started with the silent powerhouses inside the CPU, the memory. We looked at how we interact through input and output devices. And we finished with the really crucial practices of maintenance and troubleshooting. We've seen how every single piece, big or small, plays a vital role in making modern business, and really modern life, run smoothly, and how understanding it empowers you.
Yeah, and remember that hook at the start, the freezing stock exchange, the failing hospital machine. Now you have a much better sense that their reliability isn't some kind of magic. It's the result of careful hardware design, the right components working together, and the kind of informed, proactive maintenance we've been talking about today. It's tangible.
Absolutely. So don't let your learning journey end here. If you found this useful, please hit that like button. Definitely subscribe so you don't miss our future deep dives into the tech that powers everything. And share this episode with classmates or anyone else looking to level up their tech knowledge. And like we said, all the extra resources, links to the chapter, it's all waiting for you down in the description below.
And as you think about your studies and your future career, here's something to consider. What single piece of computer hardware, or maybe what aspect of its maintenance that we discussed, do you personally now believe will be the most critical for your own future success? And why? It's worth thinking about.
The future of business isn't just about what you know. It's really about how you apply technology effectively to make things happen. Thanks so much for listening.